Technology, Faculty of Agriculture Industrial Technology, Universitas Padjadjaran, Indonesia. She's also head of research center at Padjadjaran Halal Center, halal auditor at LPH Universitas Padjadjaran, Indonesia, assessor kompetensi on halal AGLSP, Halal Indonesia and Universitas Padjadjaran, Indonesia, and food safety auditor at Universitas Padjadjaran, Indonesia. She's expert in food innovation, dairy science technology, food safety and quality management and technology, organic food, functional food, halal food management and technology. Dr. Souvia has done research about food active packaging technology, spirulina as superfood, and fruits and vegetable cold pressed juice.
To Dr. Souvia Rahimah, the time and screen is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. We are here today to discuss a crucial topic that touches on consumer choices, environmental responsibility, and the future of our food system, sustainability, and food packaging. As we witness a growing global population and face challenges like climate change, and also sources depletion, it becomes imperative to assess how we produce, package, and consume our food. To discuss the topic, I'm very happy today to introduce you to our speaker, Professor Gulum Sumnu. So she will deliver the intricate relationship between food sustainability and packaging. But first, I would like to read her CV. Okay, Professor Servet Gulum Sumnu. Am I correct?
Yeah, you're correct.
Mention your name. Okay, she finished her study in bachelor, master, and PhD in Department of Food Engineering, Middle East Technical University, Ankara, Turkey, and she is now a professor in Department of Food Engineering, Middle East Technical University, Ankara, Turkey. And her area of expertise are microwave processing, such as baking, drying, extraction, and also physical properties of food, food hydrocolloid, functional food, micro and nano encapsulation, and also sustainable packaging. So I don't want to use more time. Let's begin with your presentation, Prof. Gulum Sumnu. Are you ready now?
Okay, let me share the screen.
Okay.
Just a second. Okay, thank you very much. Good afternoon, everyone. It was a great opportunity for me to be here in Indonesia, to be with you and to give a lecture on sustainability and food packaging. I am Dr. Gulum Sumnu from Middle East Technical University, Ankara, Turkey. What I'm going to present today, first I'll be talking about the future challenges, loss and waste reduction, alternative protein sources, food architecture, and finally the eco-friendly packaging. Is it not moving?
It's already moved. One moment, please. Yes, next.
It's not, we cannot. I think it's not moving there.
I'm sorry, we have a
Technical
technical problem
problems.
here. One moment, please, audience, ladies and gentlemen.
No, it's not moving. No, I'm changing, but it's not moving. Share again?
No, the committee share your presentation.
This one, right?
Okay. 22.
No, we have to go backwards. Back, not this one. Which one?
If you want to back here, back to the next.
Next year. Okay. But still one slide is missing here. Okay, no problem. Some slides is missing, so maybe it's because of the PDF. It's because of the PDF, I think. Some slides are missing there.
Okay.
2 slides are missing in the beginning. So
Start with Gulum. This is school, and this is your school.
mhm.
Okay. And share.
Yeah. The world population is growing up, and by the year of 2050s, the population will reach to about 10 billion. So it will be hard to feed these people without giving harm to the environment. And the world faces some challenging health, demography, and environmental crisis, which we need innovative solutions and sustainability systems. So there are numerous challenges that are faced by the food and agricultural industry that is necessary to be addressed. First of all, we need to feed a growing global population. There is global warming, as we are all aware. There is the decreasing pollution, waste, overfishing, and biodiversity. There is the decreasing deforestation for the food production. And at the same time, we should be ensuring that the people remain healthy and consuming safe foods. When we are talking about the safe foods, they should also be affordable, convenient, and delicious. But you know, under the pressure of worldwide spread of the new diseases, the pandemics such as COVID-19, the food industry has been under the extreme pressure. So where do our efforts go? If we consider the footprints that are coming from environment, there are a great amount of loss related to the fossil fuels, which is about 60%. And there is the loss and waste in terms of the food, which can be considered as 26%. And there are, of course, other losses that we can consider. But since the food loss and waste is a critical problem here, we have to take some precautions. Now, there's an important term that I want to mention, which is the Earth Overshoot Day. What is that? It's in fact the calculated calendar day on which humanity's resource consumption for the year exceeds Earth's capacity to regenerate those resources that year. So it's already a new concept, and when we investigate this graph, we can see that Earth Shoot Day shifts to earlier months. Well, in about 1970s, it was started. It was just December, but then it shifts to about August. Well, the next graph, which you will see soon, also shows us that the overshoot day just corresponds to August, the 1st of the August. And as you can see, our population tremendously increases, showing a linear trend, while the population day just decreases in terms of the months. So what are the major issues for the food industry? First of all, we have to consider food safety and waste. In modern industry, the foods are produced all around the world, and they are transported to shops, restaurants, and institutions. And it's critical that the industry has to find certain protocols and methods to prevent the contamination of the food from harmful chemicals, microorganisms, either to remove them or inactivate them. There is also a growing interest in changing the type of the foods that we are consuming in order to improve the sustainability and healthiness of the food supply. Why this is a great problem? Because especially for the meat production, there's a high amount of gases, the greenhouse gases that has been emitted, which really disharms our environment. So while we are changing the types of the foods, we can increase the sustainability and at the same time the healthiness of the food supply. So what are these sources? These alternative protein sources are plants, insects, microbial sources, cell cultures, and etc., which I will be mentioning all these one by one later on. So if the people change their dietary habits, it will be beneficial in terms of the reducing greenhouse gas production, pollution, land use, water use, and some biodiversity loss. Now I'm going to show you a graph which explains the gashold greenhouse gas emissions from different types of proteins. As you can see, the first one is the beef one, which has the highest one. But when we consider other sources like plant-based or insect type, that GHG values are so little. Similarly, when we consider the land that we use for rearing of animals, it is really too high as compared to plant-based or algae-based or the insect-based alternative proteins. So of course, when we produce foods from these alternative protein sources, we should consider that they should be healthy and their macronutrient composition should be similar to these alternative protein sources. Another important concept that we need to consider is in terms of the types and the concentrations of the vitamins and minerals, as well as their digestibility. Consumer, these alternative proteins should be affordable, convenient, and delicious so that otherwise the consumers will not buy them. For that reason, there is technologies in order to replace the animal proteins or mimic these proteins in terms of the look, feel, and taste. And there are different techniques for that production of these meat analogs, milk analogs, and etc., which I will be considered them soon. So there is an important word that we need to, or acronym, in other words, I have to mention, which is the matching. So when we talk about matching, M stands for meat reduced. So this is the hot topic in the world. Automation, T stands for the technology driven. C, consumer centering. H represents healthy. I, intelligent. N, novel. And G means globalization. So this is an important acronym that we should all memorize. So let's consider the loss and waste reduction. I think in the morning's presentation, there is such kind of theme that was explaining loss and waste. This is essential for our world because the number of people affected by hunger has been increased since 2015, and on the other hand, there are tons and tons of edible food they are lost or wasted everywhere. So it has been estimated that 1/3 of the food produced globally is in fact wasted. You know, this 1/3 is a great number when we consider the hunger that we are facing. Because of that, we have to take some precautions in order to, first of all, prevent the wasting, or if we cannot prevent, we can find solutions in order to reuse these wasted products in a sustainable world. So if we just look at the statistics, around 100 million tons of foods are wasted annually in European Union. And most of them comes, in fact, from the fruits and vegetables. Well, that accounts for about 20%. And also, there's high amount of loss in terms of the seafood. Of course, this is followed for the grain products, milk, egg, and etc. And we already know that that losses, first of all, comes from the production. Then there is the loss of post-harvest. There are losses in the processing stage and the packaging. And of course, there are the losses in the distribution. So food waste should increase to 200 million tons, according to the calculations by 2050, which, while an increase of 50% in food supplies will be needed gradually. So, which actions do we need to take? First of all, especially in terms of we have a wide petroleum-based industry, petroleum-based materials, especially in the packaging industry. We know that they contribute pollutions and global warming. So we should be finding more environmental solutions and replace them with a friendly and sustainable alternatives. So the examples that I can give here, we can design food packaging materials from field-forming food components, from bioactive ingredients, together with the biodegradable polymers like proteins, polysaccharides, and lipids, to replace the petroleum-based plastic packaging, or other innovative packaging materials that we can use, maybe the active and smart packaging. So it's again a recent topic which I'll be mentioning them at the end of the seminar. And another approach for reducing waste is that we can take some bioactive ingredients from these sources and encapsulate them and put it into different food materials to produce functional foods in terms of having antioxidant activity and etc. So let's come to the alternative protein sources. Why do we need them? You know, rearing of animals produces too much GHG, produces pollution, and they use high amount of land, at the same time water, and because of them there is biodiversity loss. And we all know that consumption of meat produces some health problems like chronic diseases, and the risk of the transmission of the zoonotic diseases which is recent, like COVID-19, is because of these animals. So some alternative protein sources should be searched. And the graph that I'm going to show now shows us a comparison of different protein contents, fat content, and carbohydrate values for different types of food sources. And as you can see, the pink one is the beef, the meat type of the products. But when we compare their meat with the just algae type of microalgae or insect type of products, they are similar. Plant-based ones are a little bit lower than the meat proteins, but in terms of the fat content, again, plant-based ones are better than the meat one, together with the insects ones. What are these alternative protein sources? Let me first summarize them. Edible insects, well, it's a quite recent topic, but it's again I'm from Turkey, and it's also very far away from our country, but we know that some of the Asian countries consume, and as we consider its high protein content, maybe it's worth to think about, and it's quite affordable and sustainable. Microalgae is also a good source of protein, and it's also suitable for large scale and sustainable production, and it is a high yield, and there are few species that can be considered as generally regarded as safe. And of course, there is also the plant proteins, which we are all familiar. And these plant proteins, there is a very broad range. Then there comes the cellular agriculture proteins, which are fermented from the as a result of fermentation. Then there are the edible insects, which I would like to mention, giving more information about them. More than 1 million species of insects have already been identified, and around 2,000 of them are considered to be edible. And this number is expected to grow in future. And why do we prefer to consume edible insects? Because they have nutritional profiles that are good in terms of calorie, proteins, lipids, vitamins, and minerals. And at the same time, they are a good source of essential amino acids, which are in fact lacking in some of the plant proteins. And they are also rich in monosaturated or polysaturated fatty acids, and at the same time, in terms of the minerals. And in vitro studies have shown that the protein digestibility is very high. It is more than, especially in terms of the bioavailability of the trace minerals, it is more than the consumption of the beef. So we can be thinking about why not? And compared to traditional livestocks, as I've told you, they are valuable sources of the proteins. And since they can be fat materials, they cannot be considered as waste. Somehow, therefore it's sustainable, and of course it loses less water, less GHG emissions and pollutions. But of course, there is a concern about the insect. What about the safety? Are they safe for the consumption of the most of the humans? Of course, some substances, some proteins of the insects may be toxic to humans. So more research is necessary to find out to consume these insects, and it's possible that some of them may be containing some harmful chemicals, organisms, and etc. And also inside the world, there is also a food neophobia. Well, this is again a new term. So what's it? This is the fear of trying new or unusual foods. You know, I told you that some Asian countries consume, and some of the European countries can easily consume it. And in the European project, this is one of the hot topics when people just write down the alternative protein sources. They include these insects in their projects, but still of people and developed countries, that's a potential hurdle, and people do not want to eat insects. So what's the solution? We may be using it, let's say freeze dry it or dry it, so put them as protein source in terms of the powder form, and put it in our regular food chain like breads, biscuits, yogurts, fruit juice, and etc. to increase our protein availability. Then let's talk about microalgae a little bit in details. Now, there are many species of algae in the world. In fact, they are nutritious foods. There are also macroalgae, which are already consumed, but microalgae is a recent topic which can be produced by means of the fermentation as a large scale. And there are few species that can be considered as GRAS. Of course, people just consume them. What's the advantage of using microalgae? Besides the protein, they contain high levels of polyunsaturated fatty acids. They contain bioactive carbohydrates, and they're a good source of antioxidants. And they are sustainable, and it has been shown that the production of microalgae requires much less water resources and produces much less carbon dioxide emission than the production the same amount of beef. So the environmental impact of microalgae can be great. Another thing is that these microalgae can fix the carbon dioxide and convert solar energy into chemical energy, and this efficiency is about 10 times higher than the other plants. And due to the biofixation of carbon dioxide by microalgae, it can contribute a reduction at the atmospheric GHG levels. So it may be a good strategy to reduce the global warming. And of course, the quantity and the composition of microalgae just depends on many factors, including temperature, pH, mineral concentration, carbohydrates, and etc. But further research is necessary to take these edible microalgae into our diets. So after giving you this information, now I'd like to mention a little bit about the plant proteins. We are all familiar with the plant proteins, and this is one of the most affordable and sustainable alternatives throughout the world. And you know, there is a broad range of species, including legumes, cereals, pseudo cereals, and plant proteins consider a large amount of the functional attributes that make them suitable for constructing plant-based foods. What are these functional properties? They are good gelling ability, emulsifying ability, thickening ability, water holding, and etc. So because of they have a distinctly different molecular structure than the animal proteins, we need further research and use high technologies to create analogs of the animal dried proteins such as meat, fish, egg, and milk. So I'd like to mention a little bit about legumes. And the production of the legumes requires less water than other agricultural crops. And they use less nitrogen-based fertilizers because their ability to fix nitrogen. And they're really good environmentally sustainable alternatives. So they're in fact a good source of the proteins, as we already know. We have a broad range like peas, chickpeas, lentils, peanuts, soybeans. And Turkey is a good producer of chickpea and lentils, so we have different dishes in that sense. But soybeans are, I think, are the most widely cultivated legume crop throughout the world, and they are rich in the essential amino acids that are required by the humans. There is one disadvantage of consumption of legumes, or especially for the vegetarians that do not consume meat. They contain relatively low quantities of essential sulfur-containing amino acids, which are methionine and cysteine, and sometimes lack other essential amino acids, such as tryptophan. For this reason, legumes are generally combined with other cereals, for example, rice. And generally we eat these beans or lentils together with rice, so that we are going to have a more balanced diet, because you know, these cereals contain an important amino acid, which is the lysine. Besides all these advantages, there may contain some disadvantages of consumption of legumes. These are the anti-nutritional factors that we can consider, like protease inhibitors, phytic acid. But of course, these are not a big deal, because there are some processes like boiling, baking, cooking, germinating. This eliminates these unwanted anti-nutritional factors from them, so that we can easily consume. When we come to cereals, the common one is corn, rice, and wheat. I know rice, Indonesia is the, I think, third in the world, the most producing rice country, and
Not really, actually.
not really?
No, we still imported rice actually.
Really?
To fulfill our
I
needs.
just checked and I found
Really?
you are the third
Yeah,
rice producer.
maybe compared to our population, it's not enough actually. We still imported.
Maybe. But you know, the problem in Turkey, we are in fact the producer of, as I've told you, chicken and chickpea and lentils.
yes.
Still, they're importing.
Yes.
Somehow, it's
Yes,
interesting. What are characteristic about these cereals? They are rich in sulfur-containing amino acids, and moreover, it includes dietary fibers, antioxidants, plant sterols, and other bioactive phytochemicals. But generally, most of them are concentrated in the outer layers, like hulls and bran, or the embryos of the grains. So we need to do something. For example, wheat germ is a very precious material, but that is lost during wheat milling. So we need to reuse it for different purposes in terms of antioxidant activity and etc. And some of the most common proteins found in cereals are prolamins and glutenin. And prolamins, like zein from corn, are in fact hydrophobic proteins that are commonly used to formulate plant-based foods, such as meat analogs, due to their ability to form fibrous-like structures. And compared to other cereals, in fact, oats are richer in proteins, and their contents and quality of the amino acids are in fact equivalent to the soybean proteins. There's also pseudo cereals, so they are not just real buckwheat, amaranth, and quinoa. They do not contain gluten. Therefore, this is advantageous to be consumed by the people who cannot consume gluten, like celiac disease. So in their formulation, generally these type of the cereals are used. They are rich in proteins, and their amino acid profiles and nutritional characteristics are higher than traditional cereals. And lysine is not a restricting essential amino acid, again in the pseudo cereals, which makes them useful as a dietary supplement to the cereals. I have mentioned about that low allergenity. Let's come to the cellular agriculture proteins. Due to the recent advances in biotechnology, the food ingredient companies try to use different types of microbes like bacteria and yeast to synthesize these proteins and to obtain high value added food ingredients. So how they are produced? Of course, they are kept in the fermentation tank under the optimized conditions. These microbes may excrete the proteins, or what we can do, we can in fact either disrupt these microorganisms to extract or to release these proteins. Of course, they should be isolated and purified to be edible. Although, I mean, the trend is new, we can be used for the wide range of food proteins from these sources. Now, there are different ways of creation of sustainable foods. The first one is, we take the proteins, either plant one, cell culture, insect, whatever, and we process them. Why we are processing? Because we want to either obtain a flavoring agent or coloring agent, agent, or we may want to use them fortifying some food materials or enriching their quality. Or another area is that we want to produce some meat analogs, milk analogs, and etc. The second thing is that we want to reduce the calorie of the some certain food materials. Margarine is an example, or ice cream, or for example, cake, which contains high amount of fat. One approach is using fat replacer, but recently there are the technology of emulsion technologies like double emulsion technologies, which I very frequently work on. We try to reduce the fat content of these materials by reducing the energy dense ingredients. The final item is release of the bioactives. You know, these bioactives cannot be, sometimes the bioavailability is very low in the stomach, but they should pass to the intestines. But we want them to pass the intestines without giving damaging in the pH of our stomach. So what we generally do, we encapsulate them. They are stable there, and then they will be soluble in the intestines. So we will achieve a high amount of the bioavailability. So food architecture is again a recent topic. It's in fact what we are doing, what we do. We combine all the ingredients, different ingredients, so that our product will have the required sensorial and nutritional attributes. And because of the animal-based products or proteins giving harm to environment, the food companies are searching new alternatives, new technologies to create structures that can mimic these products. So here what we are doing, we can using just proteins, carbohydrates, lipids, and by combining all of them, we are going to produce the functional foods. When we talk about proteins, they have some structuring ability. There are different ways of production of alternative proteins. In the carbohydrates, we may be using resistant starch of low sugar foods, low glycemic index foods. And for the lipid concept, we may be using fat replacer, and there are the structural design of the lipids. So we may be producing fortified foods or superfoods that we are talking about. So how does that idea come from? Again, as we have mentioned, consumption of plant rather than animal proteins resulted in a lower risk of mortality and death due to the cardiovascular diseases. And there are different functional attributes that we can get help from the plant proteins as compared to animal ones. Therefore, the food industry has been successful in creating high quality of processed meat analogs from plant proteins, burgers, sausages, nuggets, and etc. But there still need work to go on. And in that focus, we have to reduce their, our food products, reduce their calorie, fat, sugar, but at the same time, we can fortify them with vitamins, minerals, some antioxidants. So If I give more specific example, hemoglobin that is produced from microbiological fermentation has been used to produce meat-like colors. Similarly, the soybean leg hemoglobin extracted from a yeast can also mimic the colors that we use in the meat in the plant-based burgers. But still, I mean, research is going on that topic. So what are the processing methods? These are the extrusion, shearing, and spinning. I would like to mention the spinning in the eco-friendly packaging. Now, we are all using the petroleum-based materials as our food packages. You know, this causes a great harm to our environment. So we have to find solutions to replace them, environmental friendly ones. So you all know that food packaging plays an important role from chemical, physical, and biological hazards, and they should also resist odor, mechanical stress, temperature, light, and humidity. And you know, there are high amount of increase in the plastic packaging materials, and nowadays each year 23 million tons of plastic packaging are produced in Europe, and we expect it to be about 92 million tons in 2050, which is a huge number. So why do we use these plastics, you may ask me, but you know, they are really cheap and they have very good mechanical and physical properties. And it has a negative impact in the environment. As you can see, it just accumulates and gives harms to everywhere. The lands, the seasides, and the animals die just because of that. And there are, of course, different ways of recycling them, mechanical, chemical, recycling purposes, but they are costly. And in addition, they are not completely recycled, so that we can see landfilling, as you can see in this figure. So what we need to do, we have to use our renewable sources from food materials like corn, like potato skin, or the skin of the shrimp, and etc., so that we are going to produce biomaterials and use them for the packaging purposes, and then we can easily degrade them with no waste. So what are these novel packaging technologies? Active and intelligent packaging, which I want to mention them one by one. What is active packaging? The aim is to improve the conditions of the packaged food to extend its shelf life. So we can be using some antioxidants to prevent the oxidation of these food products, or what we can do, we can increase the shelf life by using some antimicrobial activity. So we have different kinds, like oxygen scavengers, carbon dioxide emitters, and etc. Intelligent packaging, another name for the smart one, is more recent than the active packaging. You know, these can communicate with the conditions of the packaged food. So we can easily, there is a marker inside these packages with it's a general color indicator. So it changes color. I mean, it may change from yellow to red, or depending on the indicator, or it may be changing blue to purple, so that you can understand that your food is already spoiled. And there are different techniques for this, like solvent casting, extrusion, and electrospinning. So I'd like to mention shortly the electrospinning, which is a recent technology, cost-effective, simple, and it's recent for food industry, but it is highly used in the textile industry. And how does this work? You know, there is a syringe where we put the polymer solution, and we obtain an electric field there. And out of that, if the electric field is, let's say, passed by the surface tension, it evaporates, and the fibers in the nanoscale can be obtained in the collector. So where do we use these nanofibers? So that's a good example for these nanofibers, as you can see in the figure, which is, in the packaging industry. It has a high surface area, so that its release properties are better if we are using for encapsulation purposes. But the bottom figure is an unexpected nanofibers, which we contain it as beads, where the environmental conditions or the solution properties like viscosity or so is not adjusted in a well way. So we can encapsulate different ingredients, vitamins, carotenoids, enzymes, essential oil for that purpose. So quickly, I would like to mention one of our studies for that purpose, which we produce active packaging material from the lentil flour, and we used it to prevent the oxidation of the walnut, as you can see from the figure. And we measured the oxidation properties like peroxide value, totox, and etc. What we have found out in the control, there were no packaging material, but the package containing nanofibers were efficient to reduce the control at a significant oxidation at a significant value. We used the same one, but this time we combined gallic acid with a gum, PMC, and we observed the same success, and we were able to reduce the oxidation of the walnuts in these packages in the active material. Well, there is one final example for the SMART, again, one of my studies. Here we use electrospinning again, and our active agent was curcumin, and we combine curcumin with chitosan, and we try to extend the shelf life of chicken. You know, we measured the TVBN value, which is which shows whether the chicken is spoiled or not. So what we observe, there is a color change. You know, our indicator curcumin changed color from yellow to red, and what we observed, as the color turned to red, we understood that our chicken spoiled. And of course, I didn't give data here since I don't have enough time, but we compare it with the microbiological analysis, and we found out that electrospinning is in fact a good way to obtain smart packaging material, just to check whether the shelf life, either we can still determine the shelf life of these meat products. It can be applied to other fish, meat, and etc. I'd like to thank you all. That's all I want to talk about. I'd be happy to answer the questions.
Okay, thank you so much for your really interesting presentation and
You're welcome.
really constructed presentation. It is interesting that you mentioned it is really future protein source, these insects. Here
Yes.
in Indonesia, we also, no, not we, in some part of Indonesia, they eat grasshopper. So they eat as chips, yeah.
Really?
Yeah, for snacks.
I think I searched a lot. I think grasshopper can be considered as halal. I'm not sure, but
Yeah.
I read that.
Yes, in according to our ulama, it is halal grasshopper. But yeah, it's still not everybody would like to.
Yeah,
grasshopper
especially,
because,
well, I can, one of my friend brought from Europe the worms, and I mean, they were freeze dried, so they look just real. So I cannot even look them. But if we really make it as powder, especially, I mean, since the food hunger is a problem, maybe it's a good source. And as I've told you, in Europe, I mean, in the projects, everyone just writes they have to include the insect proteins to their proposal to be more broad.
Okay, that's really, really interesting.
That's also interesting for me. I learned, in fact, while preparing that presentation.
Yeah. Okay. We are now waiting for the questions from the audience here. Okay, we have here with us Ibu Indira Lanti from Indonesia. She has a question. What is your opinion on the possibility microbiological food safety hazard of consuming edible insect?
I think further research is needed for this because, I mean, the insects, maybe if they are consuming some unwanted things, there may be a safety aspect in terms of microbiology. But as far as I know, these insects are produced in the farm. So I have again just searched in Turkey. There is a farm that produces that insects, and he, of course, it's not consumed in Turkey, but he directly sells it to other countries. So since it is produced in a very safe environment, I don't think that it will be a big problem.
Especially for my microbiological hazard, yeah?
Yeah.
Okay, thank you for your answer. And we have here Miss Hana from Malaysia. The world is shifting toward plant-based product. However, as we know, the protein content of animal is much more higher than that of plant-based food. What are your opinions regarding this?
Yeah, you are right. As I've shown the graph, the one that comes very close to animal protein was the insect one, I think. So although we don't like the idea, but in terms of that, but if you want to consume plant proteins, I think we have to again combine it with other sources just to have a better bioavailability of the proteins, I guess.
Yes, I think it's, I mean, insect has ugly,
maybe algae, I don't know. Algae makes more, but it's also
potential.
far from our country. So,
okay.
But it may be worth to try because it's produced in the, can easily be produced in the large scale.
Yes.
And it is safe, and I mean, we can easily eat algae, so in sushi or extra products. So although it's macroalgae, but I think macroalgae is also high in protein content.
Okay, ladies and gentlemen, we are still waiting for your questions. But meanwhile, it is also interesting when you mentioned that food waste is one of our biggest problem, also here in Indonesia. But then I've read some paper that mentioned the regulation of food expiry date. It also leads to food waste. What do you think about that?
Yes, in fact, you're right. So they show more days. This is what throughout the world what happens. Maybe, I mean, smart packaging may find an area in that respect, because you know, you can easily understand whether it's spoiled or not.
Yeah.
So by looking at the color by the naked eye, so you can understand So you are not going to destroy the food if it is not, spoiled.
Spoiled,
Especially in the, dry products, they give, for example, a 1-year shelf life, but dry product, nothing happens to it, but still we discard by, and there are also some people, I don't know, in Turkey, they don't even look the expiration date. So that smart packaging may be also a good idea for them.
Yeah, and you just need to really know
how to look.
Yeah, how to
How
look.
to look, right?
Yes, I think it's very important to educate the consumer, right? To really know when is the food will spoilage, right? Yeah. Is there any question? No, not yet. Because actually, I have a lot of questions for
Okay,
you.
you can go ahead.
If nobody wants to ask, yeah. Actually, in Indonesia, one of our biggest problem regarding of food loss is bad early handling in field. What do you think about that? I mean, what about in Turkey? Is that also happen?
Yeah, in Turkey, that's also a problem.
I think in Europe it's totally different, right?
Yeah, totally different. But in Turkey, we have a great amount of loss. Again,
In
as you
field?
can see in the field.
Okay.
But we also have a great amount of loss of bread. You know, we consume
Bread?
lots of bread.
Yes.
And it stales easily. So all the bread sometimes goes to trash. And I mean, some of the governments try to reuse that bread for certain purposes.
Oh, such as?
I think the biodiesel for that purpose, but it's quite new. I mean, for some cities they do it, but we have a huge amount of bread loss. I think you don't eat much bread. What about the rice here? Is there a rice?
Yeah, rice is still our biggest problem actually. Yeah, because everybody eat rice. And we eat like 3 times a day.
Yeah,
so,
I realize that. And we eat 3 times a day bread, so the same thing.
Yeah, the
rice
same
is
thing with
equivalent.
rice.
Yeah.
Okay. Then we have a question here. What is the nutritional profile of various alternative protein sources, and how do they measure up against animal derived protein, and how can we shift toward alternative protein sources positively impact animal welfare and ethical consideration in food production?
Now, the nutritional profile, in terms of just vitamins, mineral contents, and they have these different alternative protein sources have different advantages.
Yes.
So some of them contain high amount of vitamins, some contain high bioactive compounds. And I mean, we can can we come back to the previous question?
Yes.
Of course, it is not easy to shift towards the alternative proteins at one end. Plant ones is the easiest one. And by the way, meat industry is so big that it is hard to eat them, just completely convert to the plant one. I mean, in terms of the ethical consideration, I think in Europe, they are changing their regulations according to these alternative proteins, but not Turkey yet. But as soon as European Union does that, our country also follows them. We always follow them. So,
like you mentioned earlier, that you have to put insect in your
in the European Union
research
projects.
Okay. Okay, the project, yeah. Okay, that's
project.
How about this animal welfare issue and ethical?
I'm not sure about the ethical considerations. So,
It always
Really,
the problem for
it's
certain
yeah,
group, right?
certain group.
Yeah, not for whole group of
Yeah,
people. I
there
think
there should be some problems. Yeah, specific groups.
groups. Okay. Okay, we are going to the next question. Okay, one last question. Oh, in your opinion.
Okay,
Okay.
the advantages of the electrospinning method is that, first of all, it's cheap. Now, the other advantage is that we are producing nanofibers. You know, in the casting methods, you can only use a large amount of, let's say, in the micro size, I can say. The diameter is so big. So what's the advantage of this? If we are encapsulating our materials, we can have a better encapsulation. Plus, the release properties are better if we are using a nano-based material.
Okay, I think that's all for the question. And before we close this session, I would like to summarize your presentation, your point of view about food sustainability. I think in order to achieve food sustainability, we need resource efficiency, reducing food waste, climate-friendly agriculture, local and sustainable sourcing, and also innovation and technology. So once again, I would like to thank Prof. Gulum for joining us today in our session here.
Thank you very much.
And then I would like to hand a certificate of speaker. Okay. Yeah, here. Thank you once
Thank
again.
you very much.
Okay. Alhamdulillah, let's close our session today, and hopefully we can get our new insight about food sustainability and food packaging. Assalamualaikum warahmatullahi wabarakatuh.